Right. The final question I'm going to do in functions with you is this one off the sample paper, and it's a little bit unusual, a little bit hard, I think, for junior cert. It was as follows. The graph of two functions are shown on the coordinate grid below. The functions are f of x is equal to x plus 2 to be squared minus 4, and g of x is equal to x minus 3 ought to be squared minus 4. So the first question said match the graphs to the functions by writing f or g beside the corresponding graph on the grid. Write down the roots of f and the roots of g was part B. Okay, so one way you can do this, and I want you to try it with me now with your calculator, is let's put this into our calculator. So use a mode setup, go to table, and let's put this function in. Excuse me, because this is one way you could do this question. So let's put into the calculator bracket x plus 2, close your bracket squared, minus 4. Hit equals. Let's start our graph over here at minus 5. Let's end our graph here at 6. And let's go up in steps of 1. Okay, and let's have a look at the x values and the y values, or the x values and the f of x values. So at minus 5, my calculator is saying that I should get an answer of 5. Okay, at minus 4, I should get 0. At minus 3, I should be down at minus 3. We come down to minus 2. I should be at minus 4. Okay, can you see that it's this curve that I'm on when I put f of x into the calculator? Okay, so I want you to hit delete now, and let's put this one in. So again, bracket x minus 3. Close your bracket squared, minus 4. Hit equals. Let's again start at minus 5. Equals. Let's stop at 6. Equals. And let's go up in steps of 1. Now, you'll see in this one at minus 5, this particular graph would have a y value of 60. And the reason for that is this line would continue up, 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 up here, up, 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 up. So it'd be up at 60 at minus 5. Okay, it's gone off our screen. And minus 4 is at 45, minus 3 is at 32, minus 2 is at 21. So it's not until we get x equals to 0 that we get a normal value of 5. And you see that on your graph or on your calculator. At 1 then I have a value of 0. At 2, I have minus 3, and so on and so forth. Okay, so from that calculator work, he's the f, he's the g. Okay, so I hope that makes sense. So to explain what I did, I put these functions one by one into the calculator. I didn't know which one was which, so I started it from minus 6 all the way up here to 6. And I tried to figure out if I was to plot that one, would I be plotting it like this? In other words, would I be starting here at minus 5, 5, or would I be starting here at 0, 5, okay? And that's how I figured out which one was which. It's as if I went to plot them and I figured them out. The other way of doing it is as follows. And this is where it gets a little bit tricky, and it's outside the realm of your course. X plus 2 here means so I just solved that. See the bit in the bracket? I solved that and I got x is equal to minus 2. Okay, now that means, what that actually means is that this graph is symmetrical. There's a line of symmetry. Let me see if I can draw that a bit straighter. There's a line of symmetry in this graph down through minus 2. Okay, so that was another way that I can that I had of figuring out that that was f of x, okay? And in the same way, if x minus 3 here is equal to 0, the line of symmetry in this one is at x equal to 3, okay? So it's down here at x equal to 3. All right, so that's another way of doing it. And the minus 4 at the end just means that from here, the graph goes down. This center point here goes down 4 units, okay? You don't overly need to know that for junior cert. Okay, so the roots then, this bit is important. Can you read off the roots of a graph? So I'm going to get rid of the lines of symmetry now because you don't really need them. Okay. Write down the roots of f and the roots of g. Okay, so roots of f. Okay, so in normal English, another way of saying that is where does the graph cut through the x-axis? And when you solve a quadratic, that's exactly what you're finding. Okay, so if I was to solve that, if I was to multiply out the brackets in this one, I would get normal quadratic. And if I was to solve it, you will actually get x is equal to minus 4 and x is equal to 0 as the two answers for f of x. Okay, roots of g. Where does g cut through the x-axis? 1 and 5. X is equal to 1 and x is equal to 5. Okay. Sketch the graph of h of x. X minus 1 all to be squared minus 4 on the coordinate grid below. So of course you could put this into your calculator. Let's do it. Let's do it there. And I will tell you then what values I would ignore. So bracket red x minus 1, close your bracket squared, minus 4. Start at minus 5 again, end at 6 again, and go up in steps of 1. So when you put that into your calculator, do you see at minus 5 you get 32? So it's gone off my scale. I'm not going to plot any point that's bigger than 5, okay? So minus 4, 21, too big. Minus 3, 12, too big. Right, so the first point that makes sense there is minus 2, 5. Okay, so minus 2, 5. The next one I have is minus 1, 0. I then have 0, minus 3 on my calculator. I have 1, minus 4. 2, minus 3. 3, 0. 4, up to 5. And you can see it's 5, 12, so it's gone off it again. Okay, and then just as always, I would draw the curve as such. Okay, and label the curve then h of x. Okay, and I would draw some sort of a table down here just to tell the examiner where did I get those values from. So x minus 1 squared minus 4 to give you your y values. And we started at minus 2, didn't we? 5, minus 1, 0, 1, 2, 3. 0 and 5 for 4. Okay, so something like that. So that's how we would draw it. Okay, the other way, of course, of doing it once you know it is that the line of symmetry is at 1. So the very center of this graph is at 1, down minus 4. P is a natural number such that x minus p to be squared minus 2 equals to x squared minus 10x plus 23. Find the value of p. Right, so how would you do something like this? Well, what you do is you take your x minus p squared minus 2 and you work it out. So let's do that. That's x minus p by x minus p. Okay, that's that one. And then of course I'm going to stick my minus 2 on the end. So this is x by everything in the second bracket minus p by everything in the second bracket. And of course the minus 2. So x by x, x squared. X by minus p is minus px. Minus p by x again is minus px. Minus by minus is plus p squared minus 2. Or tidy him up, x squared minus 2px plus p squared minus 2. Okay, so now I'm going to rewrite this like this. X squared minus 2px plus p, oh, I'm going to run out of room, so let me just move over a small bit for this one, okay? So I'm going to write this one as x squared minus 2px, this is the answer I got just there, plus p squared minus 2, and that's equal to x squared minus 10x plus 23. And what we do in this case is, if the left-hand side equals the right, then all of the different bits equal each other. In other words, the x squared equals the x squared, and you can see that's the case. The x's, so the minus 2px equals minus 10x. And what I'm doing there is letting the x's equal each other. And then the numbers, p squared minus 2 is in fact equal to 23. Okay, so how I do that is I chop up my page and I let the x's x squared equals to x squared. And on this one, minus 2px equals minus 10x. And over here, p squared minus 2 equals to 23. So the p squared comes with the numbers because there's no x in it. So even though it's a letter, it's not the x that's in my quadratic. So it's just a number. Okay, so then you can solve either of these two. It doesn't matter. It doesn't matter which one you prefer the look of. Okay, let's do this one. Let's plus 2 to both sides, so that you get p squared is equal to 25. Okay, 23 plus 2 is 25. And of course, the opposite of squared is square root. Or I could have cancelled the x's here, just like that. Divide across by x. So you have minus 2p is equal to minus 10. Divide both sides by minus 2. P is equal to 5. So you could have done it in either place. Okay, this one, write down the equation of the axis of symmetry of the graph of the function kx is equal to x squared minus 10x plus 23. Okay, so I'm not 100% sure how this is going to work out, but I'm going to take this equation that I just found. I presume if I sub in 5 for x, I'm just going to get this value here. Yeah, okay. So basically they want you to take this equation and do what's done here, which is called completing the square. And I'm not actually going to do it for you because I've never seen it on the Junior Cert course. Okay, so I'm going to leave that one there. That's completing the square. Yeah. So what I would get you to do instead, actually what we'll do instead is we will plot it. Okay, so let's do that. So into my calculator, I'm doing x squared minus 10 red x plus 23. And I'm going to do it between -5 and 6 as well. And let's see what normal values we get here. So at 3, we change color again. Let's go to orange. At 3, I have the value 2. At 4, I have -1. At 5, I have -2. At 6, I have -1. And I've run out of points, okay? So I'm going to draw that curve. And can you see it's just going to continue on up there? So if I was to draw them, I'm going to see if I can draw that one better now. So 6 was -1. Okay, so let me see now if I can draw this one better. That looks more like a curve. Okay, so the axis of symmetry in this one is basically where one side folds over on the other. So the axis of symmetry in this one is the line x equals 5. Why is that? Well, you see it's going up there right through the line where x is 5. So how you describe a vertical line that through the point x is equal to 5 is as such. Okay, so this line is x is equal to 5. That is the equation of that line of symmetry. Okay, it was there. Look, I missed it. X minus p squared minus 2. It's in there. I should have subbed in. It's in there. I should have subbed in the 5, not into this one here. Okay, so if I had subbed it in there, I'd have got x minus 5 squared minus 2. And you can see then the axis of symmetry would be at x is equal to 5. But you can always plot a line, always, and see where it brings you. So that was a particularly hard question off that sample paper.